This podcast supports fumigators in improving safety, compliance, and solutions. Always follow the federal fumigant label, state and local laws. Licensed fumigators are legally responsible for their applications. And now, on to all things fumigation. Out here, we don't just fight pests. We outsmart them. This is all things fumigation, where applied science meets real-world grit. I'm John B. Mueller, a fumigator by trade, and your guide to the science of fumigation done right. Each month, we saddle up with the people, the practices, and the precision it takes to keep facilities safe, compliant, and pest-free. Because when you're in the trenches of pest control, you don't need magic, you need science, and maybe a little cowboy spirit. Smarter solutions, safer practices, managed costs. Welcome to All Things Fumigation. Welcome to episode 9 of All Things Fumigation. Appreciate everyone listening in and those that are viewing. And this episode is sponsored by the Fumigation Company. We decided to sponsor this episode ourselves, so there's not any kind of influence in the process. Not that there would be, but not perceived or real. So the Fumigation Company, if you're not familiar, we're a fumigation consultancy. We're obviously the host of All Things Fumigation, and we're really pushing and promoting fumigation initiatives, innovations, products, and then digital technology that support our industry. So also wanted to start with a viewer question. A friend of mine really emphasized the importance of including some of the responses to these podcasts that we have. And this one is from Robbie Daniels, who's a lead fumigator. And he said, we need a checklist for our clients, partners, and partners that would help us not miss crucial tasks. A checklist for fumigators, helpers, security, maintenance, quality departments, aeration, etc. And I really like this question a lot. It was after our planning and preparation phase podcasts. And I like it because it first talks about partnerships and partners. That's critically important on these industrial service events that we're partaking in. And it also breaks down very intelligently the need to include a larger community like security, maintenance, obviously quality for sure, but also maintenance as it relates to aeration and things like that. So these checklists are very important. We definitely will include this, I think, in the post-treatment review segment. And we'll kind of expand on this. There's been a lot of discussion lately around training programs. Fumigation will never be a buttons and lever service. It's pretty dynamic, but the closer we can get to identifying site-specific needs and uniquenesses, the better off we're going to be. So great insight, Robbie, and I appreciate the input. I know it's taken a while for me to add it to the podcast here, but it stuck with me. So we are on episode 9 of All Things Fumigation, and this segment is one that's near and dear to my heart, which is fumigant gas monitoring. I always have a theme to these podcasts, and this one is more of a question, right? It's, would you drive a car without a gas gauge? And I know the answer to that, right? You would not ever go on any trip. If your gas gauge broke, you would get it fixed immediately. And why? Because it would create failure in you getting to where you need to go, right? So, what's so different about a fumigation, right? So let's dig into this. When I was in grade school, I worked on a Christmas tree farm, and the guy had an old Ford tractor, and I think I started when I was like 9 years old, believe it or not. Seriously, it was a U-Pick Christmas tree farm, and the Ford tractor from the very beginning had a broken gas gauge, and we would check the gas with a dipstick, a wooden dipstick, and it drove me crazy. I just thought it was the dumbest thing in the world. And I remember one day he had a big turnip field there, and it had rained a lot, and it was really muddy, and the tractor ran out of gas, and he's walking across this turnip field, just a mess, cussing and fuming. And he'd obviously run out of gas, and I think this is a great analogy and something that I look at as I autopsy problems with fumigation in this new role that I have as a consultation to help solve some of these problems that commodity managers, food safety managers, and fumigators have. So think about this. We'll revisit that dipstick several times through this podcast. But this is a great example of a journey. I know not everybody is watching. I'll describe this to you, but it's a linear graph showing 4 different monitoring points in a 24-hour fumigation, right? And we fill our gas tank up, right? We put all the gas in the structures that we treat. It's completely full. And then we ride that out. And then based on weather and structural conditions and how well we sealed, over time, that gas concentration declines, right? And then we have to watch that decline. And once it starts to trend away from our goals, which is a CT value, right, a concentration over time value, we might have to top up. We might have to pull into that gas station and add some gas through this process, through this journey. And it's likely that we will when we're doing structures, and definitely when we're doing any number of sea containers. So to me, this is a good way to think about that process. What's going to be most efficient? And I wrestle with convincing fumigators the importance of continuous monitoring, accuracy in monitoring. And one of the things that dawned on me in a very frustrated moment was this question, of how can you use a CT product, a concentration over time product like a fumigant, and not continuously monitor? The answer is you can't. And we're going to explore some of the reasons the excuses that we use. And we're going to dispound some of these as well. So phosphine can, as one of the fumigants, so the 3 fumigants we all know are phosphine, methylbromide, and sulfuryl fluoride currently. There's some new ones coming. But phosphine can be expressed as a CT product for sure. Time, as we've discussed before, is really more important, or slightly more important than concentration, not to diminish concentration. But in a lot of the research, what we found is because of this introduction of resistance, so we have susceptible insect strains and resistant insect strains, and quite frankly, you really don't know what you have. You can have a mix of both. We've created, based on the research that's been provided by USDA ARS and Dr. Spencer Walsh, he's found a hard deck for phosphine of 500 ppm. So as we monitor, we know we need to stay above that hard deck for the period of time that we're treating based on label directions. And so again, the only way to know that is to monitor and to continuously monitor. And whether it's cylinderized phosphine or metal phosphides, it's the same. And I'm telling you, even under relatively civil tightness conditions, most phosphine concentrations are spending about half their time below that hard deck of 500 ppm, which means we're getting a sublethal kill. So keep that in mind. So monitoring is where the most potent pest control tool fails or succeeds, right? So I'm going to lay it out there. most fumigators fail. As I come into situations, as I'm hired to come in and look at how to get the potency of fumigation back on track in different operations, it's commonly the failure of effective either monitoring from a continuous monitoring standpoint or an accuracy standpoint, or the dipstick failure kind of format where it's just once a day randomly sampling. And what's really interesting is as technology advances, AI is catching some of our problems with monitoring and recognizing both environmental conditions and monitoring, gas monitoring. And AI is not going away. They're finding how to be more effective about this. More and more departments of agriculture are looking at and examining right now, with projects even, the issue and the need for connected devices, like some of these fumigation monitors. So again, several of you know me that would be listening in, and I have a lot of nails on the chalkboard phrases around monitoring that really get me. And the first one is one I heard recently. I have a guy for that. So I hear that more commonly with in-house fumigation departments, right? DIY fumigators. So commodity managers that do their own in-house treatments. And generally what happens in those situations, it becomes very layered, right? It's the quality manager who may have the license. It's the sanitation manager or maintenance person that might be involved in the fumigation. And generally it's the guy in charge of fumigation that takes these daily readings. And we'll get into the challenge that lies within that is manual monitoring comes with a lot of problems. The next one is I took a reading, right? That's the ultimate dipstick comment. So taking a few readings throughout a 24-hour or multi-day fumigation is just not very effective, right? You're trying to manage a CT product with very minimal and random monitoring. It just doesn't work. And then, I fumigated the structure many times. I have it down is another one, right? So I always say that a fumigation is like a fingerprint. It's, every single one is different. And weather is different, wind, barometric pressure, temperature dynamics. There's just so many things that change from fumigation to fumigation. Structural changes. You're making a dangerous and high risk assumption. And then the other one is monitors are too expensive. So we're gonna get into that. I always say good fumigant monitors are like lawyers. You don't want a crappy lawyer because they're very expensive, right, when they lose. And the same is true with a monitor. So don't be a dipstick, right? Let's take a look. Let's drill in a little bit more here. From a fumigation process that we've talked about quite a bit, and that fumigation process is planning, prep, setup, application, analyze or monitor, right? Ventilate and clear, and then review. And all of that, when done effectively, leads to successful treatments. So right now we're talking about monitoring, and we're right in the middle of what I call the dark period of these industrial treatments. And what I mean by the dark period is we've released fumigant, which means we've kicked everybody out other than the fumigator and the fumigation crew maybe. During the monitoring period, a lot of times it's just the lead fumigator and his right-hand person that's hanging around that's taking the readings. And I relate this to like being in school. My favorite kind of test was a self-graded test, right? So I get to grade my own test and the teacher's not in the room. So I am, the arbiter of reality in these situations. And let's be real frank here. On some of these fumigations, we see what goes into this. There's a tremendous amount of work that goes into preparing these treatments. We also see the pressure that on the customer, and they're relying on us to do an effective job. And so we're really bookended, right? There's pressure coming from both sides. And suddenly you take a reading, and maybe that reading isn't a good reading. And how do you document that, right? So most fumigations today are still pen and paper readings, and this is not defensible. And we're getting caught in this situation on a regular basis now. You know, these documents that we manually fill out are getting scrubbed in AI systems, and they're looking at irregularities. And they start to then focus on what's not believable. And it's starting to add some significant transparency to these services that we provide. So we're gonna get into that. Really think about the word defensible. It's key. So the fumigation conundrum is this: in these situations, the client or the fumigator's customer, he has to trust that fumigator, whether it's in-house or third party, because they're releasing chemicals, gases in these structures that can hurt or kill their associates. So there has to be a level of trust in these operations. And then when the fumigation's complete and people start coming in, there's a lot of discussion around, seeing dead insects in these facilities. And so obviously the fumigator did a good job, right? But then a month later, they start to see insect resurgence. And it's frustrating because they spent a lot of money and they're trying to do just one fumigation a year. And they're coming into the warmer months and they know what that means. And suddenly they're seeing live insects again. And now they come back to the fumigator and ask, what happened? And generally the first thing that's said is, well, it's been a month, And then, we followed the label. We did everything that we were supposed to do. And what inevitably happens is the fumigant then gets rolled under the bus. We start to use resistance as an excuse rather than a managed reality. We start to blame the fumigant for not being able to kill the egg effectively. It's nothing that we did wrong, right? Quote unquote. It's the fumigant's fault, and it's just not true, right? It's causing distrust. We're moving away from partnerships in solving these problems efficiently and effectively. And now we're in a divisive area where the client sometimes doesn't know who to trust at this point or who to believe, and they get very frustrated. And the reality is, and we've talked about it on the podcast before, is it takes 10 times the amount of fumigant to kill the egg as it does the adult and active stages. So when you let's think about a pro-fume fumigation, right? Let's say it's 24 hours and we're going after, confused flower beetle. Those adults and larger instar larvae, they're the ones that we're seeing that are more observable. They're dead in an hour or two, the first hour or two of that treatment, that 24-hour treatment. So then it's the back 22 hours that is being spent at killing the egg. And that is where, if our concentration starts to wane and we're not maintaining concentration, that's where we're having egg survival. And that's how we start to see adult insects at 20, 30, 40 days after treatment. That's where our efficacy issues occur. because it takes that long for that egg to emerge. It's usually younger egg phase. It takes that long to emerge from that egg to go through the metamorphic process, right? First instar larva out of the egg, second, third, fourth, goes into pupation, and then it becomes an adult. And then the adult has to come out and expose itself. And it takes that long. So that is the indicator. If you're seeing that in your facility, that means our effectiveness is not where the science that supports these products have designed these labels to provide value to you. And so, the fumigation reality is these products, they are scientifically proven effective, right? When we use them properly. And think about it for a moment. When I emphasize monitoring, the science behind this chemistry, these people are using gas chromatography and extremely advanced monitoring tools to set dosage rates, to drive the science. And if we come in with a dipstick, how can we ever follow the science? So how do you ensure fumigation effectiveness? It's accurately monitoring and maintaining these efficacious levels. I'm sure you're tired of hearing it, but why aren't we doing it with more frequency? So let's move now to fumigation economics. I think I've beat up efficacy enough. So people that know me are going to laugh now. I've been in this business for 40 years. So if I actually went back and did a financial analysis of what it cost to fumigate 1,000 cubic feet in 1996, 1997, and the cost of methyl bromide at that time was 85 cents a pound. And we were going at dosage rates to treat, let's say, grain processing facilities. And we were going at about 1.5 pounds of methyl bromide per 1,000 cubic feet. So that came out to be $1.28 per 1,000 cubic foot input chemical cost. Today, that's closer to $25 per 1,000 cubic foot and can range up to 28. So that's conservatively 20 times what it was 40 years ago. And when you look at that curve, it's one thing to say, well, okay, that was, 40 years ago. That was 40 years ago. But the fact of the matter is that's back in 1986 and 7, I would hear commonly people mention fumigation is an economic alternative to proper sanitation. Now, that is an awful thing to say, right? I never did really like hearing that even back then, but it was true, right? Flour milling operation is, high volume, low margin industry. So it's just run, the wheels off these mills. And, all they would need to do is shut down, get rid of the problem, the insect problem that had been generated, and then with a fumigation, and then start running again. And back then, to prove that this was an economic treatment, we were treating a lot of these facilities 2, 3, 4 times a year. Now it's once at best because we're 20 times the cost of what it was. So now we have to look at monitoring not just from solving the pest problem, but also managing costs. It's very, very important. So let's look at it a different way. So in 1,000 cubic feet, in 100,000 cubic feet, we're going to change the scale a little bit. We're going to do some easy math here. So in 100,000 cubic feet, then, we're putting about $2,000 to $2,500 in that space. We're floating, $20, $2,500 bills in that space. Now, if you walked in that building with $2,500, how would you protect that money? You'd keep it tucked in your pocket. You'd have it in your briefcase. You'd put it in a locked drawer, right? You'd protect that. And yet, and you'd monitor that, right? You see where I'm going. And the average structure that we're fumigating has a half-loss time of about 12 hours, which means $1,000 are just blowing out, the structure and not maintaining its presence to provide the purpose that it was put in there for, and that was to kill the insect. So we're losing $1,000. So you can start to understand economically how efficiency in monitoring can lead to efficiency of treatment and how that can render a very effective ROI, not soft dollar savings, but real dollar savings, in savings to your customer, in increases in your profit margins, however you want to handle that as a business. It's significant. And, so if we look again at another way, there's many economics that can be observed here, and all of them have a payout. So cost is relative, right? What are we protecting? Let's shift away from a space treatment. Let's talk about a commodity treatment. And sea containers hold about 40-footer holds about 44,000 pounds of material. So if we're shipping high value content commodities like pistachios, there's almost $250,000 worth of pistachios in that container. Almonds, there's just short of $200,000. With tobacco, it's a little over $100,000. With dried distiller's grains, it's only $4,600 according to Google. But there's a scale. They're doing tens of thousands of containers. So you start to look at this, and many times fumigation is a condition of sale. And unfortunately, on our end, on the export side, as we export this product, we're treating it more like a checkbox service. But if they have insects intercepted at destination, and this goes into a situation where we have to retreat this, or your client has to retreat this at destination, the costs can be staggering, right? So, and they're starting to come back on the fumigator more and more. And those costs look like refumigation costs, demerge with delays, reputational hits, hassles and distraction, more noise around fumigation, and then many times lost value. They might have to re-export that, or they have to negotiate a lower price. And I was on a project for about 2.5 years where we were looking at the cost to refumigate salvageable commodity, and it ranged between $2,300 and $5,000 per container. So again, you look at the delta between a cheap monitor and one that's accurate and connected and continuous. It's really about perspective. Suddenly, that disparity between costs disappears very quickly. Another one is also around commodities. I mean, I saw a situation recently where fumigant commodity was wheat. A large reserve of wheat was fumigated over 3 years, a couple times annually, and they were using pretty bad practices. And the cost of poor fumigation treatment was around $800,000. So they dipstick monitored, they didn't pay attention to the details, and these fumigations were not effective, and they lost grade. And then if you look at facilities today, food processing facilities that were called to come in and fumigate, they plan that shutdown for the fumigation. And if it's not effective and they have to do another fumigation in a month or 2 or 3, and it's unplanned, the cost to shut these facilities down can easily get into the millions of dollars, all because of shitty equipment is what that really comes down to. If you find this episode helpful, please like us on your streaming network. It really helps us out, and we appreciate it. And then we want to remind you to give us your feedback, the way we started this episode. We want to hear that feedback. I'll review it and share that out, and we'll learn together. So on future programming. So thank you for that. Again, this episode is sponsored by the Fumigation Company. And now we're going to move into away from efficacy a little bit away from economics. And we're going to talk about what is in a number, right? So when we're monitoring, we're looking for a numeric value. And we need to understand what that number means. It's not just a number we write in a box. That number means something. So what's behind that number? How accurate is that number? How do we determine that accuracy? What assumptions do we make? And then with everything on the line, cost and reputation, can we rely on that number? And so the tools that we've used over the years has been a whole myriad of monitoring technology. We started out, in 1986 with colorimetric tubes, Draeger tubes. We'd pull a 100 cc sample of air through that tube, and there was crystals in there, and it would discolor. And then we used thermal conductivity. We then moved on to electrochemical, and then we used PID detectors, photoionization, and then we moved into non-dispersive infrared. And it's important for you as a fumigator, if you're going to know what that number is and what's behind that number and how much you can depend on that number, you need to understand the technology that you're using. So we're going to break this down. Colorimetric tubes, they're almost 100-year-old technology. And what a lot of fumigators don't know, they never read that piece of paper folded up in the box of tubes. If you open that piece of paper up, as small as that little folded cube is, that thing opens up to the size of a newspaper. And it is full of instruction. One of those is many tubes require refrigeration to maintain accuracy, maximum accuracy. Accuracy is relative. Humidity influences this. There's a massive table on how to calculate humidity and what the impact is to your reading. And then there's an angle of color. Now, I don't want to beat up on any of our tools too much, because many of, in the case of colorimetric tubes in particular, they're decent on personal exposure monitoring, because the distance on those tubes between values is great. And it does tend to focus on the sweet spot of personal safety. But when you start to consider efficacy monitoring, you see these increments shrink down. You have a very large span of gas concentration between that same size tube many times. And that angle of color can vary greatly. And interpreting what that reading is between the high and the low stain in that tube can vary 25% at times, I've seen. So it becomes very difficult to interpret that information. And there's a great variance in accuracy, at least on the high range monitoring side. And that's what we're referencing here. The other one that came along pretty quickly after, it's around 75-year-old technology, is thermal conductivity. And think of the old fumoscope. And this unit is influenced very heavily by humidity, by temperature, by carbon dioxide cross-sensitivity and other cross-sensitivities. And I'm going to fire, I got a unit here next to me. And people that know me know that I'm not a big fan of this unit, mostly because it has a knob. And when we talked about a number, right, the monitor should give you an accurate number. And that number should not be adjustable. And with a fumoscope, you can see here, there's nothing in this room, you would hope. And I can adjust this number down to 0, right, before I take my reading. So we're at 1.0 on the flow meter. we're zeros now. And what I'm going to do here is I'm going to adjust this. The protocol I'm following expects to see 40 ounces, let's say. So I can move this up to 40 ounces. Even though there's no gas in this room, I can take a picture of this reading, and then I can take that picture and add that to my post-fumigation report, right? And now this is time-stamped and geo-stamped, and surely that number is accurate, right? That's what's happening. And that adjustable knob has to go away. We can't use monitors that can be manipulated because it's being done too much. And again, what's catching this is AI scrubbing information and looking for disparities, things that are not plausible in our fumigations. So we'll get into, I guess, the next phase that we need to look at. The next iteration of gas monitoring was mostly centered around phosphine in our fumigation industry, and that's electrochemical. And electrochemical is a very different type of sensor. It's more of a static sensor. It can use a pump or not, and in most of the personal monitoring settings, it doesn't use a pump. And these are very good for personal monitoring levels. But when you start to utilize this technology for high range readings, we have saturation issues, right? With phosphine in particular, we're seeing as much as 1,000, 2,000 parts per million. And that sensor gets overwhelmed, and then it doesn't want to clear. And the more frequency of exposure to higher concentrations, the more it wears this sensor out, and then starts to drift in terms of its accuracy. And then there's also some cross-sensitivity issues with CO and some other things with our fumigant gases we're observing. So I tend, these can be used. They are utilized in our industry, and they are USDA approved and acceptable, but they're not the most accurate. PID detectors, they're newer technology. They're mostly centered around use of methyl bromide. They're more of a litmus test, right? So it's non-specific monitor. So it's looking at air balance and saying there's something in there that doesn't belong. And it can be dialed in to be a little more specific to methyl bromide in particular, but it's more of a litmus test that says there's something here. Now use another device to validate what that is and that the atmosphere is safe. And then something that I've been a part of really pushing in the industry since actually about 1999, but in commercial practice since about 2005, is non-dispersive infrared. It's widely known as being very accurate. I used a lot of carbon dioxide in the 1990s, and we had a very economical carbon dioxide full range monitor. I think it was 1994 or 95. Very accurate, very compact, and it was an excellent tool for using high range carbon dioxide. And I always was frustrated that we didn't have NDIR for our fumigants. And then along came 1999. We were introduced to a company called Spectros Technologies. We started to work with them. They started to work with some of the newer fumigants that were coming out. And lo and behold, we started to utilize that technology. And where my judgmental behavior around these fumigants come from is really the search to feel good about the number I was getting, right? I was noticing that mathematically these numbers weren't meshing up. And we'll explain this a little bit later on, but things weren't weren't right about some of the technology that we were using. And so what I would do is, like in the case of high range electrochemical for phosphine, I would stick 5 different um, electrochemical monitors, 5 different ones in the same spot. I mean, same spot. And I've literally seen 5 different readings, on average, 3 different readings that can span a disturbing span of concentration. And it just drains you a little bit. Now, how do you know if that number is accurate or not? So when we first started using this, because this technology, it's not cheap, it's not expensive either, it brings value. But I would run, the first time I ran 3 of these units in the same spot, and I got nearly the same reading. I think it was the same reading. And that gave me confidence. And mathematically, that reading was plausible, right? So I really started to get excited about this, but I also knew that there was so much more that this technology could bring to the industry. So very reproducible, very consistent. And then this technology's moved into connected devices as well, and we'll touch base on that. From an economic standpoint, one thing I want to point out is manual personal monitoring is absolutely the most expensive form of gas monitoring that's out there. To pay an associate to manually stay around and manually monitor a fumigation, without a doubt, is the most expensive way to go. If you look at this objectively, you will realize that. And we've got a picture of a person here with a gas mask on and a monitor. And you know what? I'm not beating them up. They're taking readings. That's important step number 1. But there is a much safer and more effective way. So let's look at the cost of monitoring on what I call an accuracy matrix, right? If we have a monitor that's super accurate, that's how we get to solving the pest problem, right? So if we have a monitor that's 5% off, and all of them state their variability of accuracy. And so if we're 5% low or 5% high, what does that mean? So 5%, if we're 5% low and we're paying attention, then we're adding gas that doesn't need to be there, right? So every $10,000 of gas we're using, we're having to add another $500 in there to stay on track, right? It's costing us money. Now, if you fumigate very much, you can see how better technology, yet again, can be paid for very quickly. Now, 5% could be either way. It could be accurate, but if it's 5% on the high side, it's giving you a false sense of security, right? So now that's where insect mortality ding comes from, right? If we're 5% high, we may not be hitting our number because we've got not enough in there, and it's reporting that we do have enough gas in there. And you can run the math the other way. You go 10% either way. Now it's $1,000 for every $10,000 worth of gas you're using. And some of you out there are using hundreds of thousands of dollars in gas. So, if not more. So, this starts to put perspective in the true costs of monitoring effectively. And then there's the remote nature. Look, I did this. I wasn't a desk jockey these 40 years. I was out physically with the crews. And, when it came time to monitor, I needed a shower, I needed a meal, I needed sleep. And now you have to sit down and monitor for 24 hours or come back every day for, 5 or 14 days. And it wears you out. And to have peace of mind to connect these devices like NDIR that is accurate, you feel comfortable, the number is solid, and now it's pushing data to our phones or our computers, and we can go get that, go get that shower, take a quick look at that reading. We're trending good. Go eat at the restaurant with your crew. Everybody pulls their phones out. You have productive conversations about, how it's going. Sometimes there's excitement, sometimes there's concern, but there is collaboration and partnership through these events. And then you're generating what's most important is historic data. You're generating defensible data. Now I'm going to quickly go into another phase of economics on this. What I learned very quickly, I couldn't afford to spend the money on this technology when we first got food protection services going. And I quickly learned we couldn't not afford it either. And here is the first example that happened. We were doing a mill fumigation. We had this fumigation down. It was a relatively tight structure, but we had used good monitoring data to really get this fumigation down. But we continued to monitor. And about 2 weeks after a fumigation, that was just a rock star fumigation from a graphing perspective. About 2 weeks later, our customer called and said, "You sent us insects, come defend yourself." So our milling customer called me and said, "My client's angry, come defend yourself." So I quickly printed off the data that I had. We went down, we met with their customer and listened to them first, and they were very irritated. And we showed them our process, we showed them the data, and their demeanors kind of changed a little bit. They calmed down. And then I asked, let's start with your process. Where do these rail cars come in? And let's follow the process where the flower moves through. And literally within 10 minutes of this tour, we found what the problem was. It wasn't our customer's issue. It was their customer's issue. They were very civil about it. They accepted, responsibility at that point. But then what happened over the coming months is our customer, their customer, ourselves started to have conversations. We had a couple other meetings talking about improving the situation at the milling facility's customer. And then we ended up picking that business up, which ended up being more than revenue than what the milling operation was lending. So when I hear people say that this technology is expensive, that's absurd, because it's quite frankly the opposite. I've seen the same scenario in DIY operations when you were talking about defending reputation, and in these situations when they're selling a high value commodity to a processor, and they know they can rely on that commodity, and they're not going to be shipping them insects, and their competition is. That's yet again how, through reputation, you build business off reputation. Defensible data is key and understated when we talk about investing in technology. All right, again, we want to remind you, if you find this episode helpful, please like us on your streaming network. And, again, give us your feedback. We want these suggestions for future programming. We want to learn together. This last comment, question, ask was very valuable. This episode is again sponsored by the Fumigation Company. And we're talking about gas monitoring, and we're going to get into how to monitor. I talked a lot about rabbit hole issues maybe with monitoring, and a lot of kind of deeper understanding of the importance and what is behind monitoring and what's behind that number that's generated. I want to go into a series here of some tips to give you as takeaways. The first is really intuitive, right? When we're applying fumigant, we want to monitor away from application points. We want to challenge these treatments. So we want to see where, if there's failure or any kind of lagging areas, we want to be able to monitor those areas. And then the other issue is with monitoring equipment is the need for backups. A friend of mine that I worked with, Ron Tulsma, came from the military. And I learned that this is a military saying, right? One is none, two is one, and that can't be more true than we're monitoring. It's true when we're monitoring for safety, and it's equally true when we're monitoring for efficacy. If we have one monitor and that monitor goes down, and we're depending our reputation on that, then we have no recourse, right? So if we have a second one, we can either utilize both at the same time for efficiencies. More data points are good things. And if one goes down, we've still got the other one to secure the service. Always start your electric monitors ahead of time, at least a week ahead of time. I see this as a problem too much, where they grab the monitor before they go to a job and they fire it up right about the time they're ready to apply fumigant. And there's an error code, or there's something wrong, something missing. Power cord, Wi-Fi connection, whatever it is. This has to be done in advance. So you have to commit to this technology. It will absolutely help you and make your life easier. But you can't beat on it like fumigators do to a lot of our equipment, right? Let's be honest. And then part of that commitment is seeking to understand these error codes that we see. The Spectros unit in particular has a booklet, and I have never seen an issue where that number, that error code, didn't get me to a solution. It's usually a solution that's pretty quick and now, and sometimes it's not, and you know not to fight it, and the unit might need to be sent back. But it doesn't happen that much. It's pretty robust equipment. And then you need to triage that equipment before calling tech support. You need to understand what to communicate with them. Now, there's also issues of calibration. And one thing I want to point out is most of these units have annual calibrations as a minimum. Sometimes, when you have unclearable errors, you need to calibrate, get repaired, and calibrate more frequently, especially on the electrochemical side. But how do you know if that number starts to become less reliable, right? And it really comes down to this dose concentration relationship. As a fumigator, you should understand that, right? Your dose is not 16 ounces. It's not, 1,000 parts per million. Your dose is based on weight, and your concentration is what that dose gives you. So like in the case of sulfuryl fluoride or methyl bromide, they're measuring this, they extrapolate this as dose suspended in the air. So we're talking about 16 ounces per pound. We're dosing pounds per 1,000 cubic feet, right? So if we're dosing 3 pounds per 1,000 cubic feet, then we should know that the concentration that we should expect theoretically is 48 ounces. If we're not seeing something close to 48 ounces, either our volume calculations are off or there's something wrong with the monitor. Same true with phosphine, right? 1 gram in 1,000 cubic feet is 25 parts per million suspended in the air. Now, 40-gram dosage rate is then 1,000 parts per million. So don't worry about writing this down, taking a note or anything. This information is in your fumigant manual, application manual, but it's really important to know this dose concentration relationship. So next we're going to get into post-fumigation analytics. We've got a whole episode at the end of this fumigation process that talks about post-fumigation reporting. We're going to add checklists and SOPs, but we also need to stage some of our activities to supply consistency in our reporting, right? So being consistent around your monitoring placement and even your application placement. Now, that's not to say that we can't vary from that, right? So I always like to put a monitoring point near elevated insect activity so I can watch that. But then I think it's important to also monitor on a more consistent basis. So if there's a building that's compartmentalized, I want to make sure we're dosing that accurately. If there's a floor, if there's multiple floors, I want to be able to monitor every floor. And I want to monitor that consistently so I can look at data from one fumigation to another, and there's not unexplainable variations in that data. Always keep in mind if you dose too heavy in a compartmentalized situation, you can't usually move that gas from one restricted area to another. So I'm also watching the accuracy of dosing based on those compartments. And then also bioassays. I think, placing monitoring lines or placing bioassays near monitoring points is important because I feel that you shouldn't be just monitoring the adult stages of insects. You need to have metamorphic array, so egg, larva, pupa, adult, and you need to know what those concentrations are in case you get some results that aren't great. You've got data specifically to that. So in summary, accurate gas monitoring is not expensive. That's just an excuse. Cost management is a big part of kind of this period of discovery that you'll have as you monitor continuously, and you have this data to compare over time, and you can learn to either cut back or make whatever adjustments. It is defensible data. It's a reputation protection. And then gas monitoring, at the end of the day, it's how we fulfill the purpose of fumigation, right? And that is to solve the pest problem. So don't be a dipstick. Connect your devices, connect your accurate gas monitoring devices. Our theme is be a science cowboy, apply the science and protect your product. Part of the science is very accurate gas monitoring. I want to remind everybody that we are having a post-harvest fumigation school. The theme of that school is applying the science of fumigation. It is designed to be an advanced, kind of a master class in fumigation, and every speaker and or presenter and hands-on session head will provide a train the trainer format and kind of take home to the booklet that'll be completed at the end of the school. So this is June 9 and 10 coming up in about 2 months, and we'd love to have you attend. If you'd like to register for the fumigation school, if you're viewing, we're showing a QR code here that'll take you right to the registration and payment. If you're listening, just remember to go to our website, thefumco.com, click on events, and there you can register and pay right online. Made it as easy as we can. So that's the end of our podcast. I am John B. Mueller, a fumigator by trade, and your guide to the science of fumigation done right.